the slope of the first one, and we know the slope of the third one. We don't know any of the other slopes. Would you agree with that?
Yeah.
Which means we have to solve for y to do that.
Mm-hmm.
Okay. So the one that's probably fastest to solve for y is line 4.
Uh-huh.
To do that, let me just make some room here. Y plus 7 equals -1/7x plus 4. Sorry, that's in parentheses. Now, when I say solve for y, what I really mean is mx plus b. So it's a little more than solving for y. You have to distribute this -1/7.
Uh-huh.
So it's -1/7x minus 4/7. And then you can move the 7 to the other side of the equation. You can subtract 7 from both sides.
Yeah.
So this is y equals -1/7x minus 4/7 minus 7. Now you might be wondering why we're not going to combine these. It's because you only need the slope. And does this calculation affect the slope?
Sorry.
Does this value affect the slope? This -4/7 minus 7, does it affect the slope?
Mm-hmm. No.
No, the slope is just the number in front of x. The slope is -1/7.
Uh-huh.
Okay, so let's go back up. Is your final exam multiple choice?
Yeah, it is.
Okay, so you have enough information here to actually get the answer.
Mm-hmm.
We know, for example, that 1 and 4 are not parallel. So B is out because they don't have the same slope.
Uh-huh.
All 4 lines are parallels out because they're not all the same. So it really comes down to either 1 and 2 are the same or 2 and 3 are the same. Okay, so actually I take that back. We do have to find the slope of this last one here. Let me rewrite it down here. X plus 1/7y equals -6. So again, your goal is to solve this for x. I'm sorry, for y. Sorry, solve for y. Subtract x from both sides.
Mm-hmm.
So this becomes 1/7 times y equals -x minus 6. And then how do you clear that fraction in front of the y?
Multiply by 7.
Multiply by 7. Yeah, and you multiply everything by 7. So -x becomes -7x minus 42. What is the slope of this equation?
-7.
Yes. So if we go back up to our list here, now we can get the answer. We know that the lines that are parallel have the same slope. That means that, well, 1 and 2 are parallel.
Okay.
Are you comfortable solving equations?
Yeah, pretty much.
Okay. Like nothing I did there was something you couldn't reproduce.
No, but I think we should try some maybe.
Okay, so let me give you some equations here. Y minus 2x equals 3. 3y minus 2x equals 4. X equals y minus 2. And then we'll do one more here. Y minus x equals 4. Okay. All I've done here is write 3 equations in kind of 3 forms. I'd like you to give me the slope of each of them And really what I'm saying is to solve each of them for y.
Yeah.
There's not that are two that are parallel here unless that happened accidentally. So give that a shot, please.
Wait, so I'm just trying to solve both of them for y?
Because I just want the slope of each of them.
Oh, okay.
But you can solve them to do that, you really need to solve for y.
Okay.
How are you doing on this?
Um, I mean, I got the first one. I'm still doing the second.
Okay.
Okay, so I've solved them except for the second one, which
Okay. Yeah, give me the slope of the first one then.
so for the first one I got 1.5.
Okay. So let me just clarify. We're adding 2x to both sides.
Yeah.
So it just becomes y equals 2x plus 3. So your slope would be just 2. So there's no division. You're only dividing if there's a number in front of y.
Okay,
Okay.
okay.
But let me work these out with you. I apologize. I really thought that this was something that you were already comfortable with. So let me yeah, let's go to this last one here. You're solving for y. Y has a 1 in front of it. It's almost solved for. If you add x to both sides, you can't add it to the 4, so it just goes up in front, x plus 4. What is the number in front of x that's not written?
1.
Just a 1. So that last one has a slope of 1. This
Oh,
this third one here, you can get x alone by moving the 2. You could add 2 and kind of flip the sides, or you can move the y by subtracting y, but I would probably just add the two, excuse me. On the left, it's x plus 2. On the right, it's y. But you can then flip sides. Y equals x plus 2.
okay. It's because I think what went wrong is like when I added a variable to both sides, for example, I'd make it like 4x instead of x plus 4.
Yeah, you can't combine the number and the variable.
Mhm.
Okay, now let's look at that second one. 3y minus 2x equals 4. Like you said, we're gonna add 2x to both sides, but this time you cannot combine it. You have to kind of sneak it in front. It becomes 2x plus 4. But we're not done. We haven't solved for y. Um, how do we do that? How do we undo this 3 in front?
Uh, Multiply it by 3, or sorry, divide it by 3.
Divide by 3, and you divide everything by 3,
Mhm.
which means that your slope, it's y equals 2/3 x plus 4/3.
Uh-huh.
And there it is. You've got it.
There's this one. Okay.
Okay, so we go back to our list here. I guess we can say that something about the slopes here, these two are the same. So they are parallel. Let's look at one more. Well, we should maybe move on. Do you want us to move on to number 2 or do some more problems like this?
Maybe let's try again.
Okay. So let me give you y minus 1 equals negative x plus 3 minus y plus x equals 1, and 4x minus 4y equals 4.
Okay.
Negative 4. Negative 4. So I want you to find the slope of each of these, but you do have to solve them all for y.
Okay. So for this first one, is the slope 1?
Slope is -1. That negative goes to both of
Oh,
these.
yeah.
So it ends up being y minus 1 equals -x minus 3. And then you actually don't even care by adding this 1, but it ends up being -x minus 2 or -1.
Uh-huh. Okay.
Okay, how about for the second one there?
Second one. Like for the equation, like that I got at the end, like -y equals 1 minus x.
I mean, this is okay. You really want keep x in front. Like I would have preferred to see it as -y equals -x plus 1.
Mm-hmm.
But then the way you have it's fine. It does work, but you just have to get y alone. You have to undo this negative.
Mm-hmm. So multiply it by a negative.
Exactly, or divide everything by -1, however you see it. That changes the signs of everything.
Uh-huh. So then the slope would be +1.
Yes.
Okay. And then for this last one, I'm not sure if I did it right, but I got -1.
Okay, so let's just take a look here. I'm going to subtract 4x from both sides.
Yeah.
And again, it's better to put it in front. I know that that's awkward. It's weird. It's like, why would I do that? 4x minus 4. And then we'll divide everything by -4.
Mhm.
So that becomes y equals 1x plus 1.
Yeah, I got y equals -x because been I mean I put it backwards. I put it -4 minus 4x instead of flipping it.
So that's okay. I mean, it's okay to do that. minus 4x, but when you divide by -4, you're dividing everything. And so the negatives in front um, would cancel.
Oh, okay. So it would just be 1.
Yes.
All right.
Okay, we really should move on. I know maybe that's still not clear, but there's enough examples here that probably you can look back on or try again.
Yeah.
Okay. All right, so the next problem here is to solve and graph an inequality. I remember that you were pretty strong with these. There's nothing unusual about this one. Do you want to try solving that?
Yeah. So this one just W is greater than or equal to 2.
How would that look on a number line?
Uh,
Like imagine that's
like,
2. Is it shaded left or right or both or neither?
like it'd be filled in and then everything to the right.
Yes. You got it. All right. Do you want me to give you a more challenging one, or should we save that for, I guess, 2 questions later? Maybe we should do that one next.
Yeah.
Let's actually do that one next. Okay. All right, so when you multiply or divide by a negative, it flips the inequality. That's what you have to remember, take into this. Because your goal is to get z by itself.
Mhm. So if you multiply or divide by negative, flips that equality. Yeah, okay. So if you multiply both sides by -4.
-4. And that's what I mean by multiplying by a negative. So it
Uh-huh.
doesn't matter like if that initial number is negative, it's if you're multiplying by a negative.
And then it flips it. Yeah.
Yes.
So and just z is greater than or equal to -8.
Greater than or equal to -8.
Yeah. All right. And then
What would that graph look like? Which of those four there, A, B, C, or D, would you choose?
let me just
Siempre me ha gustado que lo pregunta.
okay, sorry.
Which of those four graphs is it?
Oh, D, right?
Yes. Very good. So the thing you have to remember is this multiplier divide by a negative flips the inequality. That's the key to
Yeah.
doing these correctly. All right. We go back to the previous problem with the table now, or do you want more inequality problems?
I think I'm good with the inequalities for now.
All right, let's take a look here. All right, Richard has one quiz each week in a computer class. The table gives the probability of having a quiz on each day of the week. That's actually probably a good idea for most of you guys, you students out there to do that, to see which day was more likely to get a quiz. You probably already do that. So the table gives you the probabilities. The sum of them, the total, should be 1 if you add them all up. Now we're asked, what is the probability that Richard will have a quiz on Tuesday, Thursday, or Friday? So or in probably generally means plus, and generally means multiply. So you've got to add up the probabilities for Tuesday, Thursday, Friday.
So 0.28, 0.13, 0.36. So what is that, 0.67?
I mean, there's only one that's even close
Yeah.
with that. What if it said the probability of not Monday? You know how to interpret that if it says not Monday?
Like what are the
What would the
probabilities that
yeah?
it is
How about this? Yeah, what's the probability that it is Monday?
like one?
Let's start. Let's do that one.
Yeah. Like, would you?
That's just 0.19, just 0.19, because it's that value.
Oh,
So now not Monday,
would be all the other values combined.
yes, or 1 minus 0.19, like you said, or it's the probability of Tuesday, Wednesday, Thursday, Friday. 0.81.
Okay.
Okay, sorry I threw that at you. I thought that you guys, it sounds like you've not covered much probability in there.
Yeah.
All right. So here you go. Here's another problem to look at. Multiply d plus g to the power of 2. This is a special product, but if you don't remember the special product formula, you have to write it as two binomial product. Two binomials multiplied together.
Uh-huh.
Okay, so now it's a FOIL problem.
Yeah.
Okay. When you take d and multiply it by d, what does that become?
D squared.
D squared. Okay. All right. And all the answers, well, actually letter D does not have a d squared, but that's okay. Yeah, I was thinking maybe we could eliminate some. How about d times g?
Is
What does
that
that be?
EG?
It's just dg. Now, when we multiply g times d, it's better to put it in order,
Yeah.
alphabetical order. That's kind of the standard. You know, you put your weights back on the rack in the order they're in, right? We just have conventions that we use.
Yeah.
So now what is g times g?
G squared.
G squared. All right, so if you look at the answers, none of them match what we have written here, but you can typically always combine the O and the I.
Mhm.
Okay, so this is 2 DGs.
Yeah.
Let me give you another one to try, if that's okay.
All right.
Let's have you try x plus 6 squared.
X plus squared. Okay. Um, um, okay. X plus 36. Okay, x squared plus 12x plus 36.
Very good. Okay, now you know enough to try number 8. Will you try number 8 again?
Uh-huh.
Well, actually, you have the right answer there. So let me give you one that's different. Let me have you try E minus F, E plus F. Will you try that one?
Mm-hmm. Okay, so yeah, e squared plus negative f squared.
Yeah. Or just E squared minus F squared? Yeah.
Yeah.
Really good. All right. Can we move on to problems like 10 now?
Yeah.
Okay, great. Why didn't that snip so well? Okay. All right, so a problem like 10, it's sometimes good to scan the multiple choice answers. You will notice something. In fact, you probably see that they all have different slope. 5, -5, 1/5, -1/5.
Mhm.
If you correctly find the slope between the 2 points, you will find the correct answer. I haven't asked you, do you get an equation sheet or reference sheet to take in with you on the test?
An equation sheet?
Yeah, formula sheet, cheat sheet.
Oh, yeah, they do give us like.
Okay. So you probably will have this formula,
Yeah,
but having the formula isn't all that useful if you don't know how to use it. The ordered pairs are x1, y1, x comes before y. The subscripts just mean that it's from the first ordered pair, and then x2, y2, x and y, and then 2 because of the second ordered pair.
mhm.
Okay, so I'd like you to use those in this
Okay.
formula here and let me know what you come up with for the slope. It should be one of these answers. Those are famous last words.
Okay, so I'm pretty sure it's D.
Okay, so your slope, you're saying -8 minus a -3 over 1 minus 2. Does that look at all like what you have?
Yeah.
So -8 minus -3 is -8 plus 3. 1 minus 2 is -1. -5 over -1 is +5.
Oh. Okay, I was looking at like. Okay. All right. So yeah.
Okay, so let's continue this on. Let's just like we know the answer is A, but let's talk a little bit more about it. I'll give you some more slope to do, but let's say you wrote y equals 5x plus b. To find b, you have to use one of the ordered pairs. So do you want to use the first ordered pair or the second ordered pair?
The first one.
Okay, so that means that y is -3, x is +1. Sorry, 2. Sorry, not +1, 2. And we have enough to solve for
Yeah. So. So
so we have, go ahead.
is B -13?
Yes. And that matches with what we found in the previous problem here.
Yeah.
Okay. So we shouldn't be surprised by that. Okay, so let me give you two new ordered pairs. -3, comma 1, comma -5, comma let's go 9. I want you to find the slope between these 2 points, please.
Okay. It's y1 minus y2, right? Yeah.
Nope, no.
Y2.
Sorry, and let me give you the formula because you'll have it on the
Y2.
yeah.
Okay.
Yeah.
Okay. Is that -4?
Slope, you think it's -4? Let's take a
Or
look here. So 9 minus 1, I'm not sure. -5 minus a -3. 8 over -2, which is -4.
yeah.
Good. Now, y equals -4x plus b. I want you to use either of the points to determine the value of b.
Okay. -3 plus b.
Which ordered pair are you using?
I'm using -3 and 1.
Okay. All right, let me know when you get your b value.
Okay, so I added the 3 to both sides.
Okay, you're multiplying first. You have to multiply before you can do that.
I thought it was 4x.
It is. It's -4x, but
Oh,
you're putting that number in for f.
okay. I wrote it as I put 3 still in front of -3 still in front of x. Okay, let me give me a quick
Yeah,
second.
recalculate.
Okay, so is it -11?
Yes, you're subtracting 12 from both sides, so b equals -11. That goes right in there.
Mhm.
Okay. So let's do one more of these where I give you we've already found the slope. So sorry, plus or -11. So let me give you a new problem. Let's say we find that y equals -1/3 x plus b, and I tell you it goes to the ordered pair 6, -4. And I want you to solve for b.
Okay. So -4 equals -1. Six plus B. So is B -2?
Okay. That is possible. Let me see here. So it's -4 equals -1/3 times 6
Mhm.
plus B. So when you multiply these together, -1/3 times 6 is -2. So you add 2 to both sides, and yes, you get B equals -2. Good. You feel better about those types of problems now?
Yeah, I do.
Fantastic. All right, so the next type of problem here is asking about direct variation. Before we do that problem, maybe we make one up like it. Direct variation means that y equals k times x. So an example would be like y equals 2x.
Mhm.
Okay, there's no number being added or subtracted, but it could be a fraction. Like this is also okay. 1/4 x. This is okay. All right, now let's look at some equations here. Let's go x equals 3y minus 1. Let's go 5x plus 1 equals 3y plus 1. And let's go x equals 4y divided by 3. Okay, so let's look at, and actually, I'm sorry, let me do it differently because I want to work these out with you. I don't want you to have to.
Okay.
So let's look at these three. Tell me what your initial reaction is to the first one. Is it direct variation or not?
The first one?
Yes,
No.
it is not. So if we solve it for y, notice we're solving for y again, it becomes x plus 1 divided by 3, which is x divided by 3, 1/3 plus 1/3. This is a big no.
Uh-huh.
But the one on the right here, or I'm sorry, the one in the middle here, well, can that be solved for y? And that's really where you want to, you want to go. Okay, like what can you do with the ones?
You can or subtract them from both sides.
Right. So even though initially it's got extra numbers, it's okay now. So how would you solve this for y?
I would probably divide by 3 on both sides.
Yes, very good. So if we switch the sides here, y equals 5 divided by 3 times x. Is this direct variation?
Yes.
Yes, it is.
Okay.
This one's okay. How about the last one here? What do you think about the last one?
3. We multiply by 3.
Okay, so that will get rid of the 3 on the bottom. So it's 3x equals 4y.
And then
What did you do in the previous problem? How did you undo this 3 in front of the y?
divided by 4.
Yes. So this becomes y equals 3 over 4 times x.
3 over, yeah. And that is
That's
okay.
okay. Yeah. Now the other type of way you might see it is this, it's the last one I guess we'll do, where it's like x, y equals 4. And then the other one you might see is x over y equals 5. We'll just do that. So one of these is direct variation and one is not. So it's, you have to solve for y in both of them. Like, how do you get y by itself? How do you undo this x here?
Divide by x.
Divide by x, yeah. This is 4 divided by x. Is this direct variation?
Yeah.
Well, it's got to be k times x, a number, and then x. No
Oh,
fraction bar.
so no.
One's a no, big fat no, which means the other one is, but I'd like you to solve for it. Please.
Here you multiply by x.
Yeah, multiply by y. Because y is on the bottom.
Oh. So then, yeah. So x equals 5y. It is
X
direct
equals 5y, but we've got to solve it for y, which means we have to undo.
multiplication.
Yes.
We divide by 5.
And this is okay. This is y equals x divided by 5, which is okay.
Okay.
So that takes care of direct variation. I think we're up to problem like number 12, least common multiple. So let's take a look at that. So 3m to the 4th, n squared, 6m to the 6th, n cubed, and we're looking for what's called the least common multiple. So that's when it gets bigger. So you look at the 3 and the 6, and you're looking for where the multiplier gets like if you go up from 3, 3, 6, 9, and so on, 6, 12, etc.
So 3m.
Well, it's the biggest, the least means you have to go up, you have to get larger. Like what's the first place where 3 and the 6 intersect? And it's here at 6 and 6. So you gotta be careful between LCM and GCF. You were giving me the GCF,
Oh, okay.
which another problem, that would be great, but not in this one. Okay, so that takes care of the number. Now with the letters, you have to look at it as you want the bigger exponent.
Right.
So you want the bigger exponent this time, m to the 6th.
You don't want the least common multiple of the variables.
But we're gonna do the other one. We're gonna do the n now as well. So
Yeah.
the least common multiple means it gets larger.
Right.
So now we're looking between n squared and n cubed. We want the larger one, n cubed.
So for the variables, you just want the larger exponent.
Yes. But again, it's easy to confuse these because we don't differentiate between them well for who knows why. Let's do another one here, if you're okay with that.
Yeah.
So let's find the least common multiple between 2 x to the 5th y cubed and 9 x to the 6th y.
Right. Okay, so the LCM of 2 and 9 is 18, right?
Okay, good start.
And then x to the 6th and y to the 3rd.
You got it. Now, should we do a greatest common factor, or do you think that will be covered on the
I didn't see it on the thing, but for
Okay.
example, if we were to do greatest common factor, it would
Okay,
just
so it's kind of going the other direction, but let me give you one that's like kind of nice, like 2x to the 5th y cubed and 4x to the 6th y squared.
so then it would be 2x to the 5th y squared.
Yes, so you go smaller.
Yeah, all right, that makes sense.
Okay, so we've got some time left here. Let's keep going. Looks like you did, just looking real quick. The 13s, these are hard to make up. Do you have questions on how to do 13? Because you've done it well. Okay, yeah, there's a problem here. I'm sorry. Your answer looks so clean, but small issue, unfortunately. Okay. So first thing I noticed here is that when you have a negative exponent, and you're gonna have, based on this, you're gonna have some problems with negative exponents. You only flip the thing with the negative exponent. So there's an 8, r to the -2, s to the -3. The 8 does not have a negative exponent.
Oh, so only the r squared.
So it'd be 8 s cubed over r squared.
Uh-huh. And then
And then for the other one, it's kind of the same thing. It's if it's negative, it goes to the bottom.
so like 3 s cubed r squared.
Yes.
Okay. And then you can simplify m to get,
Yeah. Now because the bottoms are the same, you can then subtract
yeah, so it's just 5 then.
5s cubed over r squared.
Yeah.
Let me see if I can make one up like this for you to try. If that's okay.
Over r squared.
Yeah, because the 8 and you can subtract the 8. 3 subtracts from the 8.
Yeah. Okay,
All right.
I was just thinking about like canceling both of them. But okay, yeah.
Okay, so let me give you one here. How about let's go 9. X minus 3 y minus 12 y to the negative. Yeah, I guess I don't want to change it that much. -1 x to the minus 3.
Okay. Oh. Oh. 9 over x cubed minus the first x cubed so is it -3 y over x cubed?
Good.
Oh,
Okay, enough time to tackle the last one here.
okay.
Probably almost better if I just give you the rule here. So this is c to the 5th, d to the 7th. Whenever, well, let me break it. This is the square root of 121, the square root of c to the 5th, and the square root of d to the 7th. It's 3 separate square roots. Square root of 121 is 11. Kind of helps you, but since none of the above is there, not super helpful.
Yeah.
The c to the 5th becomes c to the 4th times c to the 1. Okay, you always go down by 1 in your exponent. And then you further break this apart into square root of c to the 4th times the square root of c. Now, the reason that's useful is the square root of x is really x to the 1/2. So whatever exponent you have in here, it's n divided by 2. So in your problem, it's 4 divided by the 2 for the exponent. Think of this as c to the 4 divided by 2, and that becomes c squared. Square root of c. Have you seen that before, or does that look totally new?
I've seen it before, I think.
Okay. This d to the 7th becomes d to the 6th times d to the 1. Square root of d to the 6th times square root of d.
Mhm.
So the same thing for this one here becomes d to the 6 divided by 2 power, which is d to the power of 3. And then you bring the 11 down.
So there I'm a little bit confused when we like divide the exponents.
That's the so the simple rule is you just divide the exponent by 2. But notice that 5 and 7 don't divide by 2. That's why we break it up. It
Mhm.
comes from the fact that the square root of x is really x to the 1/2, because there's really a 1 above the x and a 2 is what's called the index of the root.
Yeah. Okay. So essentially. I'm trying to- Yeah, that kind of makes sense. So is that basically just the rule to follow?
Yes, yes. So we can make one up here and like, well, let's finish this one off. So it's 11 t squared d cubed square root of c times d.
And you just combine those c and d square roots.
Yeah.
Okay.
So real quick here, let's just say it was 64 x cubed. It's the square root of 64 times the square root of x cubed. Square root of 64 is 8. Square root of x cubed is x squared times x to the 1. Square root of x squared. Square root of x, it becomes 8x. Square root of x.
Yeah, okay.
So the rule to remember is that if it's an odd exponent, you divide by 2. And you're going to have 1 left over inside. All right, we do unfortunately